Hey everybody, welcome back. Today we're going to be working through question 2 of the W22 midterm exam. And this question is all about call-er and callee saving. So quick recap, call-er saving is the interaction between a main function and the functions that main function is calling. Essentially, that main function takes responsibility for saving the value inside any registers or the designated register if it needs the value inside it to be retained after it returns for the function from the function. Essentially, it's the responsibility of the caller. That's why it's called caller save. In callee save, we have the interaction between a function and the function that called it, and essentially we have this behavior, which I like to think of resource acquisition is necessitates saving. And essentially, if I'm the function that's called and I have to allocate a variable to a particular register, I have to make the assumption that the value that's in there holds some significance. And so before I put my own variables values into it, I need to move whatever values inside that register to another place in memory. And then before I return, I need to restore that value. Awesome. So we can go ahead and get started. We're going to start with caller saving. We're going to go all the way down, and then we'll do callee save, and then we'll make some decisions about optimal register allocation. So we're going to start with variable a. I see that it's declared right here. So caller saving, again, we need to consider every time this function in exam is going to call another function, right? Because that's what's going to result in some form of caller saves. So before we do that, we need to consider the liveness of variable a. So a is declared in that first, or I guess the third line. And every time I see that we're going to be reading the value of a right here, right? And so every time that loop runs, I need to be able to read that value. And so my liveness, right? Variable a is going to be live for the entirety of that loop. Variable a is also going to be live for this statement because we're reading the value. And then because we're reading the value here, variable a is also live. So variable a is live for all of this function except this last function call on line 12. So how many times are we calling functions between, while a is live? Well, let's consider it. So we're going to be, how many times, I guess, is this for loop going to run? That's going to be something we need to consider. So if we look at the syntax, we're going to start at 0 and we're going to iterate until we hit 3. Essentially, this function is going to be called 3 times in this loop. So we're going to have 3 caller saves because every time I need to save register a before I call foo and then restore it after I call foo. So that's going to be 3 saves there. We're also going to have one function call here and one function call here for when a is live. And so we're going to have a total of 5 caller saves for register a. We're going to do similar analysis for register b. We see that, we see that register b's or variable b is declared on line 3. It looks like variable b, or the register associated with variable b, is not going to be live for this for loop. And the reason for that is we never, have to read the value of b, right? And then we immediately follow up by overriding the value of b in line 7. And what that means is we don't really care if somewhere between here, right, the register associated with variable b gets changed to a random number, right, it's not going to affect the behavior of my program at all. And so, and because I want to minimize the number of caller saves or just saves in general, there's no point in me saving register variable b in that range. And so b is not live for that for loop. The only place we are going to access register B, or we want to read its value, is here on line. I can't tell if that's 11 or 12, but essentially we can just look at the scope between when the value of B was modified to when it was read last, right? So it's going to only be live from line 7 to, I believe, 11. So I guess how many function calls are we going to make in that range, right? Well, I'm only going to call foo here, I'm going to call foo here. So I'm going to make 2 caller saves. Variable C, similar analysis. Okay. So probably shouldn't have done that. It's fine. So variable C is declared on line 3. So if we expand this statement, that's the equivalent of saying C is equal to C plus 1, right? So the only place I am reading variable C is right here. And so I don't need, C goes kind of out of scope after that. So what we really care about is only the range from line 3 to the first and I guess last time that we read the variable C. And so how many functions do we call between these 2 lines? Well, we're going to call foo again 3 times in that range, and we're going to call foo 1 more time here. And so we're going to have a total of 4. So we're going to do 4 callers. For the last one for this function, we're going to look at variable I. So this is like our iteration. So every time, right, every time I loop, right, or at the start of every loop, I need to read I, right, because I need to compare it to A. And so essentially, I is going to be in scope for the entirety of this loop. It quite literally goes out of scope if you consider it in the syntactical C sense after this function. So the scope or the liveness of this variable only extends from 4 to 6. So how many times are we going to call foo in that range? It's going to be just 3 times. Excuse me. Now we're going to look at variable D. Variable D is declared on line 3 of the function foo. So printf should because we're passing the variable D in, right? And we never actually like when I'm passing a variable as an argument, right? I am essentially performing the read first, right? I'm reading the value that's in register D, and then I'm handing it off to printf. So, in terms of ordering, we don't need to call or save D before printf, right? Because we're reading the value first. What we'll see is that nowhere else in the rest of the function do we actually read the variable D. And so the liveness of D extends only from like lines 3 to 4, right? And so as a result, we're not going to have any caller saves because there's no functions called between those 2 lines or before the printf. Next, let's look at variable E. So variable E is declared on line 3 again. And so it looks like on line 5, we are reading the value of variable E because that's equal to E minus 1. So I'm reading variable E. So I know it extends at least past the printf. And then we proceed to override the value that's in variable E on line 10, right? And so it doesn't really matter if I change the variable E between lines 6 and 9 in that while loop, because I'm going to end up overriding the value in it anyway. So E is live between lines 3 and 5, right? And then let's look at, we have another live or scope that comes, starts at line 10. And then it looks like the next time we read it after that printf is going to be, we're going to do E is equal to E plus 1. And so this other scopes can extend from lines 10 to 12. As a result, we're going to have one call or save, right, for this first print statement on line 4. And we're going to have another call or save for this print statement on line 11, right? So we have two call or saves for every time that foo is called, right? So it'd be really easy just to, pencil in 2, but the consideration that we need to make is that we need to account for how many times foo is called. So how many times is foo called? So we'll have to look at in exam for this. So we call it 3 times in the for loop. We call it once on like line 8, once on line 10, and once on line 12. And so in total we have 6. So foo makes 2 caller saves for variable E every time it's called, and it's called 6 times. So we're going to have 6 times 2, which is going to give us a total of 12 caller saves. Awesome. Let's go ahead and look at variable f. So variable f is declared on line 3. It is then read. Next time I see the variable f being read is on line 6, right? And so, it's definitely going to encompass, our liveness is definitely going to encompass lines 3 to 6. And because this is a while loop and we're going to need to read f every time, in addition to like line 8 being f is equal to f plus 1, so that's also in scope there. The entirety of this while loop is going to be in scope, or live, or variable f is going to be live for it. It's going to continue to be live on line 10 because we read the value of f. And I believe that's the last time that we read variable f. And so after line 10, it goes out of scope and it's no longer live. So how many function calls do we have in this range, right? So we have their first function call on line 4. And then every time this while loop runs, we are going to have one function call, right? So how many times this is going to run? Well, I believe so. We start at 1, and every time we iterate f, and we're looking for strictly less than. So essentially, we're going to loop from 1 to 5, iterating by 1, and so this is going to run 4 times. So we have one caller save up here, 4 caller saves down here, and so we're going to have 5 every time foo runs. So again, we're going to multiply by 6 because we need to count for the number of times foo is called. And so in total, we're going to have 30 caller saves. That's the entirety of caller saving. Let's go ahead and try to do callee saving. So callee saving is essentially only going to occur whenever a function tries to declare a variable, right? So in exam, we can assume that in exam is called once, right? In the instructions. And so when that in exam function is called, we declare a, right? Which results in 1 callee save. And then, that register is allocated to variable a for the entirety of the function. Very similar to B, C, and then, we're declaring I on line 4, and that's still a declaration. It's still trying to acquire a register. And so that's going to result in another callee save. Awesome. Then for foo, really similar thing, right? We're going to have, when we declare D, E, and F, those are all going to be callee saves. But again, we need to account for how many times foo is called, right? So we have 1 callee save for each of those variables every time foo is called, but foo is called 6 times. So we're going to have 6 times 1, 6 times 1, and then 6 times 1. And awesome. So now we've calculated in our program how many times, if I chose call or save, how many times something's going to be call or saved. And the same thing for call e saved. So now we are told that there's only 2 caller and 2 callee saved registers. And so we're asked to decide which one's optimal, right? Remember, I can only associate 2 of them with caller and 2 of them with callee. So what I'm trying to optimize for is the net number, or I'm trying to minimize the net number of saves, right? So caller save. So let's kind of like look at each function, right? So I only need to analyze it within the scope of this function. So A, B, C, and I, of those, 2 of them have to be caller and 2 of them have to be callee. So let's see. So it looks like for all of these, right, callee saving would be better, right? Unfortunately, I can't say all of them are callee save because I only have 2 callee registers. So which ones are preferable? Well, if I want to minimize, right, essentially, I'm going to look at the difference at each of these points. So if I choose caller A, if I choose A as caller, I'm going to perform an additional 4 saves. Whereas for B, I'm only going to perform an additional 1 save. And then, for C, I'd have 3. And for I, I'd have 2. So I want to minimize that value, or really I want to maximize the number that I'm saving, right? And so I'm going to callee save the ones for which, it would make the biggest difference. And for the others, I'm going to caller. Right? So if I had 4, if I had 4 caller and 4 callee, and ideally I'd make these all callee, but unfortunately I'm limited. So then for our second function, we're looking at variables D, E, and F. And so I can do a similar analysis. So it looks like D would be better caller saved. And then both E and F would be better callee saved. So for this one, it's a lot easier to make the decision because I have more than enough to make the optimal decision for each one of these, right? Because I want to minimize the total. So here, I would make the following decisions. Awesome. That is all I have for question 2. Hopefully I'll see you guys next time with question 3.